We will try to integrate this and later differentiate this. Okay, it's a very long question in this video. Alright, but before I start, let me just explain why you need to do this exercise very seriously. Because in a single exam, for example paper 1 in O levels, you can have a variety of integration expressions that you need to integrate. So you need to be able to organize in your mind and not be confused by algebraic versus exponential expressions. Okay, so algebraic expressions don't have this e here. Okay, when you see this e and then there is a x at its power, is what we call exponential expression here. Okay, whereas for algebraic, pure algebraic, right, you only have the x, you don't have the e to the power of something. So if I have algebraic expression, the very first thing I need to do is to express it in the form a x to the power n. This is the big X made up of bx plus c. So what do I do? Very simple. The very first thing is all the doggy, the constant outside remain. Then the big X, right, also remain. You add 1 to the power of the big X. Okay, then divided by the new power, and then you need to differentiate this and put your answer here. Okay, and when you integrate like that without the limits, without numbers here, right, you must always plus c. Okay, now contrast this with exponential expression where you have a constant and e to the power of bx plus c. Now when you integrate exponential expression, all you need to do is to photocopy whatever they give you. Photocopy, you see the one in blue I photocopy, right? Okay, then I differentiate this and that's my answer. Okay, differentiate, then you divide for integration you divide, for differentiation you times. Okay, later I'll go through differentiation. So an example of, let's say this is, okay, if I have integrate, a is a number, okay, a then over x, differentiate, integrate with respect to x. Now you will notice that in this case, when I express in the form a x to the power of n, then I plus 1. Okay, this is an algebraic expression, right? Algebraic, this is algebraic. Then I plus 1 to the power, it will be 0. Then I divide by 0, it will be not defined, right? So in such a case, it's a ln case. Ln whatever is the x here. Okay, later I'll show you another example, this one. Alright, if I have this where this a and this a are constants, p and q are constants, x is a variable, then you will find that, okay, this whole thing is power 1, right? Again, when I bring up, you will be you'll be having the same problem of dividing by 0. Now in such cases, you just write the constant a as it is here, the doggy just stay here, the constant a just stay here. Then you ln whatever you see here, this expression here. Okay, don't get me wrong, if there is a b here, you don't go and ln the b, okay? You let the b remain where it is. Let the b remain where it is. You only ln this part here, okay, which makes up your big X, and then you differentiate this, you get p, right? Then you divide by p. Okay, so that's how you do it. Later I'll show you on the question itself. Now let's get started with this particular long question. Now the very first thing, as you remember, right, whether it is algebraic expression or exponential expression, the very first thing you need to do is to express in the form a x to the power n. So that's what I'm going to do now. A is your 0.3, x to the power n, because it's power, there's no x here, right? It means power 0 because anything to the power of 0 is 1. So actually it's 0.3 times 1, but we don't write the 1 there, okay? Same here, expressed in the form ax to the power of 1, ax to the power of n, and that is 4 over 5 x to the power of 1. Ax to the power of n, you must make sure these comes to the numerator, okay? So this is your a, minus 2 over 7 x to the power of n. A is your minus 4 over 5 x to the power of minus 1, okay? You bring this up. Same here. Now we have entered the zone of the big X. Big X means this whole thing here, okay? So you need to bring this whole thing up and become minus 1. Same here. Ax to the power of n is already done, so I don't need to do anything. Ax to the power of n is already done, I don't need to do anything. This one I must do something because the big X is at the denominator, so I need to bring it up. So it's now a, which is minus 4 over x to the power of n. Okay, this one we have entered the exponential zone, so don't get confused. It's no longer like algebraic expression, it is exponential. So now this is your a, which is plus 7 over 2 e to the power of another function. Same here. Okay, this e to the power of 4x at the denominator, I need to bring it up so that it becomes a e to the power of fn, and then I go on. Okay, this one, same thing. I need to bring it up into the form a constant, e to the power of another function, 5x minus 4. Okay, this one, there is no such thing, because this is integration, there's no such thing as quotient rule or product rule for integration. So you need to simplify this expression first into the form ax to the power of n. Ax to the power of n. Okay, so I have expanded this, combined it. This times this is minus 14x squared, then this times this is minus 6, then combine this with this with this, you will get 25x. You double check, okay? Now, only in this form, ax to the power of n, ax to the power of n for algebraic form, then you can integrate. Alright, now we will start integration, okay? So first step, remember, express in the form that you can integrate. Now we are going to the next step already, and I'm going to do one by one. Okay. This one, by the way, I have not done any integration yet. Do you all notice? I didn't do any integration. I only do makeup. I only change it to an equivalent form. That's why this thing, integrate with respect to x, is still around. Okay. Now I'm going to integrate. Okay, how do I integrate? If you remember, it is power plus 1 divided, wrong one. Power plus 1 divided by the new power, then differentiate the inside, the big X, then you get this. Okay? Okay, so power plus 1 divided by new power will be this. That's first one done already. Next one, power plus 1, that will be 2 divided by new power. That's it. Actually, we actually have to differentiate x, but because differentiate x is 1, so you times 1. You divide by 1, is still the same answer, you see. So we don't show that working. Don't need to show that working. Okay. This one, power plus 1, that's minus 3 divided by the new power. Okay, and then actually you need to differentiate the x, but it's 1. So you divide by 1, it's the same answer, so I didn't write. Okay, this one, when I take power plus 1, that will be 0. Okay, 0, you're going to divide by 0, not defined. That's why this is a ln case. Okay, how to do ln case? you just ln whatever this power minus 1 the argument is. So this x is called the argument. So you just ln the argument, that's it. But you must differentiate the argument, and that's 1. I just write here just to help you know what is the formula, okay? Next one, same thing. This whole thing is the big X. It's like linear law, the big X. So I bring up already, then power plus 1 is 0, divided by 0 not defined. So this is a ln case. Now after you have done this, don't forget to differentiate the big X, then divide. Okay, for integration you divide. For differentiation you times minus 2. Okay, that's it. Next, this one power plus 1 divided by the new power. Then you must differentiate the inside the argument to get minus 3. Next, power plus 1, that will be 9 over 2. If you don't know why, you just take 7 over 2 plus 1 on your calculator. Now leave your answer in improper, okay? Then next step, you divide by 9 over 2. But I don't like to write 9 over 2 here because it makes the whole thing look very complicated. So I flip the 9 over 2 and it becomes 2 times 4, 9 times 45 and all that. Okay? Then you must remember to differentiate the inside, then divide by that because you are integrating. Don't forget we are doing integration now. Next, power plus 1. Okay, everything you see the number, the doggy just stay only, the inside don't change anything. Power plus 1 divided by new power divided by minus 1, then differentiate the inside, so that's minus 3. That's it. Okay, next we have entered the exponential exponential expression kind of zone. So exponential, just photocopy, you see 7 over 2 e to the power of 4x. Then differentiate this function here, this power function here, then you'll be 4. That's it. You divide. If it's differentiation, then you times. This is integration. Next, photocopy exactly the same. Photocopy, then differentiate this function, divide. That's it. Next, photocopy, differentiate, then divide by minus 5. Okay, differentiate 4 minus 5x is minus 5. Okay, next. Same here, photocopy, differentiate the function, divide by the answer. This one is very simple. You integrate 6x, integrate 6 is 6x. Then power plus 1 divided by new power. Power plus 1 divided by new power. Then because there is no limits given, they just ask you to integrate this. So you need to put the plus c. Okay, now we are going to the last step already. The last step is to simplify whatever I've done in the previous step. Okay, so this one actually you can straight away come here. I'm just showing you step by step what's going on. Now this, please use calculator if you are not good at mental calculation, okay, which actually many of you are not good. So you just press your calculator, whatever sign you see, then use the fraction symbol on your calculator to help you compute the answer. So if you had pressed correctly, you will get this. Then for this, you press on your calculator minus 2 over 7, then you put the times minus 3 at the denominator and you will get this. And please leave your answer in positive index, so you bring this down. It's now at the numerator, bring down to the denominator, and that's the answer. Next, just remove the 1 and that's your answer. Next, combine this to be minus 5 over 2. So remember, it's always sign, number, algebra, then check your work. Okay, snack, sign, number, algebra, so called. Okay, next. Press calculator, you will be able to get this. Okay, then this one just leave it. Next, Press calculator. Okay, you press using the calculator fraction function to do this. Don't use mental. They will give you this answer. Okay, don't waste time, don't waste your brain power using mental calculation in the exam, because you need your brain power to do more difficult questions. Okay, this one just simplify, 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 so on and so forth. Okay, so I think this part is very clear. Okay, I'm now going to do the reverse. Okay, from here, before you watch or continue the video, right, can you try and differentiate this, or differentiate whatever answer you have, and see whether you can get back the same. Alright, now definitely this one you won't be able to get back this you won't be able to get back this, because this one is we expanded, then we get this, and then we integrated, then we get this, right? So when you integrate when you differentiate later, right, you won't get this you have to like do something in order to get this. Alright, but basically the idea is there. If you had integrated correctly, when you differentiate, you should get the answer. Okay, so the next thing we're going to do is this whole long question. Okay, very long one, longer than just now that one. Okay, this is differentiation, because differentiation there are more things involved. Why more things involved? Because integration, there's some limitation to what you can do, and you might learn some of the things only in JC. Okay, but differentiation, you actually can do a lot, so you have more things. Okay, so differentiation, remember, it's the power you throw down, right? You times this original power, then power minus 1, and if there's a big X here, you need to differentiate the things inside the big X. Okay, now let's see how we can do this. This is straightforward. First thing I need to do is to make sure all my expressions can be differentiated. What do I mean by can be differentiated? It must be in the form a like big X to the power n. Okay, meaning that this must be at the numerator. Same here. It must be for exponential, right? It must be in the form a exponential symbol, then to a function. This must be at the numerator. These two must be at the numerator. These two must be at the numerator. Same for just now. Integration. They must be at the numerator. Okay. So the very first step I'm doing now is to ensure that they are all at the numerator. Ax to the power n. Ax to the power, this fella, you see, the x is not at the numerator. I got to bring it up, so there is ax to the power n. Okay, ax to the, this one, no, this one is a long function. Long function, you just copy as it is. Long function, then this one is ax to the power n. Very good. Ax to the power n. Very good. And next, this fella is not in the form ax to the power of n, right? It's not. Is the x is at the denominator, so I got to bring it up. Okay, so that is in the form ax to the power n. This is big X. Now it's exponential already, so ae to the power of function, ae to the power of function. This fella got to bring up, because it's at the denominator now, cannot. Okay, this one, okay, this one cannot, got to bring up. And this one, okay, this one I've got to say something. Now when you have these some complicated thing times some complicated thing, or some complicated thing divided by some complicated thing, right? The one that is multiplied together, you can group it like that. Okay, that means you yourself decide where you want the minus to belong. Normally we put the minus with the first one. Okay, then the second one no minus. Okay, square root means power half. Okay, same here. I'm grouping these numbers together with this algebra at the numerator. Why? Because this value is 6 pi over 1 times x squared. So it's 6 pi x squared. Okay, over this, so this is at the denominator. So for this, you have to use quotient rule. For this, you have to use product rule. We will see how to do it later. So this is the new thing that is not in the previous question that I showed you. Okay, now we will start to differentiate already. Okay, I may be very like troublesome here, right? I write a lot of things, right? But I'm just trying to tell you it's power times this, then power minus 1. Okay, then actually you need to differentiate the x, which is times 1. Differentiation you times, integration you divide. Okay, so after I've done this, I can do this. Same thing, throw down. Next thing, same, power minus 1. After you multiply, then you power minus 1. This one, when you differentiate ln, right, it's just 1 over whatever the argument is, then you differentiate the argument. Okay, so I think just now I didn't go through, right? Yeah, I didn't go through. Okay, so for example, if I ask you to differentiate this, just write the doggy as it is. Differentiate ln is just 1 over whatever is in the argument, then you differentiate the argument. That's it. Then you combine them together, is a over bx. Okay, now a more complicated one would be this. Doggy, a number a and b, they are numbers. I call them doggy, just stay only. Then you see a ln, right? You want to differentiate ln, you just put 1 over whatever you see here, the argument, then differentiate the argument and you times the argument. If it's integration, then you over p. Okay, if it's integration, then you over p, but if it's differentiation, then you times p. Alright, so very simple. When we integrate, we divide, okay, by whatever we have differentiated. When we differentiate, we times whatever we have differentiated. Alright, so I think we shall move back to the question. Okay, this next one, next one, doggy is minus 5 over 2, stay here, then 1 over whatever you see in the argument, then differentiate the argument, 7 minus 2x, you get minus 2. That's it. Okay, then you combine using calculator, minus 5 over 2, then times minus 2. That's it. Alright, next, throw down the power, multiply by the power, then power minus 1, then differentiate the argument inside, that's minus 3. Okay, do the same here, minus 4 over 405, then 9 over 2 you multiply, power minus 1 you get 7 over 2, differentiate 5 minus 2x, you get this. Okay, oh sorry, I repeat, this one you just throw down, then power minus 1, then differentiate the inside, that's it. Okay, now next we are doing this question now, this one. Okay, so power you multiply by power, then power minus 1, then differentiate the inside. You see, it's always the same old story. Okay, we have entered the exponential zone. You photocopy, differentiate the function at the power, then multiply, because this is differentiation. Okay, so in the exam you must always ask yourself, am I differentiating or am I integrating? Okay, then do the same here. In this case it's minus 4, and this one, do the same, photocopy, differentiate this, you get minus 5, so you multiply, that's it. Okay, this one same thing. Okay, differentiate the power, you get this. Alright, now we have entered the differentiation of function times function and differentiation of function divided by function. So let me just slow down a bit because this is very important. You need to know how to differentiate this. Okay, so as mentioned, group this as one function, group this as another function, okay, and change it to the index form. Now product rule is very simple because product rule is just adding the two things together. So what comes first, the thing that you see first, right, you differentiate first. So when I differentiate this, I throw the 2 down to multiply by this, I get minus 12. Pi is just a number, leave it. Then power minus 1, so I get 1. Okay, now the second function, leave it. So very simple. What comes first, differentiate first. Don't touch this. Then secondly, right, after the plus sign, the second term that you are doing, you already differentiated this just now, so now it's your turn. Okay, so this is what I get for the product rule here. Okay, alright, very straightforward. You see the second one, right, this one don't touch. I differentiate this. How? Throw the half down, this one copy exactly the same. Power minus 1, I get minus half, and differentiate the inside, I get minus 8x. Okay, then what do I do after this? After this, later then I tell you. Okay, now let's go to quotient rule. Quotient rule. Now for quotient rule, you write this template first. Draw one long line, put a minus here, then square the denominator. So square the denominator first. When you square this square root, right, you get 1. Okay, it's like times 2 to half, you get 1. Everything else remains the same. Now, same format. What comes first, you differentiate first. What comes second, you differentiate second. Okay, very easy to remember if you use this method. You won't get confused in the exam. Okay, so I hope you will learn it this way and not the textbook way. Alright, differentiate this, you get 12 pi x. This one just photocopy, don't do anything to it. Okay, this one now leave it because just now you already differentiated. Differentiate this now, so throw the half down. This one power minus 1, differentiate the inside, minus 8x. Okay, so you have done the integration already. Differentiation already. Okay, now go back to, so you see in the exam, you see I was talking just now, then differentiate, integrate, very confusing, right? In the exam, it's the same thing. So always ask yourself, am I differentiating or am I integrating? Okay, because in the exam, there's a variety of questions and you will get confused. Alright, now it's time to simplify. Simplify, you get this. Now you must be able to simplify correctly, otherwise all your efforts are wasted. Okay, so you see here, I made a mistake. It should not be this because x to the power 0, anything to the power 0 is just 1. So there's a mistake here. Differentiate this, should be 0.3. Okay, next. Simplify this, you will get this. Now I really recommend you press the calculator to help you. This times this, then use the fraction symbol over 21. They will give you minus 2 over 7. Okay, then you yourself must write it in positive index. Okay, this one nothing much to simplify. You just put the x there. This one okay, press the calculator, minus 5 over 2, then times minus 2, they will tell you it's plus 5 over 7, 5. They will tell you it's plus 5. Okay, then this part here is simply this part here, that's all. Okay, next. press calculator, you get this. Then press calculator, you get this. Press calculator, you will get this. But make sure this you bring down to the denominator, make it positive index. Okay. Then you see down here there's a minus. This times -1 times -3. That's why overall is minus. But please use your calculator and always use snack sign number algebra. The sign follows this -4/15, you know. Many of you will forget that this minus belongs to this, and then you end up with just 4/15 times -1 times -3, which gives you a positive number. So that'll be wrong. So remember, it's always sign number, sign number, sign number. The sign follows the number. Okay. Next. Okay, just write it in positive index. Alright. Okay, this one just leave it. This thing just leave it. Okay, this one just leave it. Okay, because you don't know originally that it's like that. You don't know. So this is the correct answer already. Okay, now this is what I want to focus on. How to simplify this part here. How to simplify. Okay, we focus on this one first. Remember, it's always sign number algebra. SNACK, snack. Okay, so what do I mean? You check. Oh, sorry. Before that I simplify first. I simplify first. What do I mean by I simplify first? I check sign minus, only minus, right? I put minus here. Number is, this pi is a number. So number is consisting of 12 pi, and then the algebra consists of x and this power half here. Okay, do the same here. Sine, you see, sine is -6. Sine and the number, right, is -6 times -8. So what you can do in the exam, right, you can actually put a tick using pencil. You can put a tick. Okay, I settled this already. -6 I settled. -8 I settled. Half I settled. So what do? You using snack, right? Sign number, you times this number times this sign number. Okay, so you settled all the sign and the numbers, and you will get 24 if you press correctly. Okay, now it's also, I didn't put the pi. Okay, so 24 done already. So this 24 settled. Alright, then now the algebra consists of what? X squared and x, so it's x cubed. So you have settled this. Now you really need to do like what I'm doing now, because many of you are cubed by all these small little things. Okay, you may think that very troublesome. You just want to see and then you write. I can tell you, under exam condition you'll make mistakes. Okay, and then finally is this algebra. Okay, so you can see that when I did everything is covered. Everything is covered, so I'm correct here. Okay, now I'm going to move on how to simplify. Again, okay, just now what I've done is to simplify them individually using snack. Now I'm going to use snack again to take out common factor. If they want you to show a certain expression or prove certain things, this is what you need to do. Okay, so sign, any common sign to take out, don't have, I put a plus. Okay, then I see what is common. So I take a look. Wait, I'm going to, that's why I say in the exam it's good to use pencil so that you can erase and then now you do the ticking again. Okay, okay, now I'm going to do the ticking. Sign, nothing to take out. Number, I'm talking about taking out common factor for this and this. Number, yes, I got 12, you got 12, I take out. Okay, wait. Alright, take out this 12 already. Then I got pi, you got pi, I take it out. I got x, you got x or not? Yes, got x, I take it out. Then now between you and me, we will take out the smaller one. The smaller one come out first. Okay, the smaller one come out. So you will stay, you will be taken out. Okay? Any more things that we missed out? Don't have, right? Don't have, okay, don't have. Now you see, I again go and erase this. Why erase this? Because I now need to account for everybody and make sure that whatever I've written inside this. Okay, so another good practice is to write these red brackets, square brackets. Then all those things that you write here will be multiplied by here to give you this. And multiplied by another one to give you this. Okay, so let's try and see. So I take a look at this and I see 12 times what will give me minus 12. Because just now I only took out 12, I didn't take out minus, So there must be a minus here. And the 12 settled by this already. The pi settled by this already. The x settled by this already. And this, you must ask yourself times what will give me half here. Okay? So it must be 1. Alright? So this one also settled. So you see everything settled and everything ticked here. Okay? Now I'm going to do for this other side already. Okay, now of course if you are very good in your algebra, then you don't need to do like what I do but many of us are not. Okay, so next one already. I'm looking at the things across this plus here. Okay, so 12 times, okay, firstly settle the sign is plus 12. Is it correct? Yes. Then I want 24. 12 times what will give me 24? Must be 2. Okay, then there's a pi here. I already got pi settled. Okay, then I got x cubed there. So I have one x here. What must I put here to have x cubed? X squared. Done. Then I have this 5 minus x, 4x squared whole thing minus half. Yeah, I already have here already. So you don't need anything, just a 1 here. Okay, done. So that's how you do it. Okay, then now you see this right here, but when it's minus power, right, you got to throw it down, and I throw it down, right, actually it's a square root then the thing inside the square bracket, right, why I like to write square bracket because it's to remind myself that I still need to expand and combine, simplify the square bracket. So this times this is minus 5, this times this is 4x squared plus this 2x squared is 6x squared. Finish. Okay, no need to expand, leave it like that. Okay, leave it like that, because later you may need to factorize this or find whether increasing, decreasing function or whatever. Okay, so this is how you simplify this. Now we are doing the last part already. Video ending soon. How do I simplify this after this step? Remember just now we were at this particular step. Okay, same thing, very powerful. Use the snack. Okay, now firstly, is there anything to simplify for this individual term and this individual term? Yes. So this one actually nothing to simplify because the numbers are together already. The algebra, okay, but this one, right, the numbers are everywhere, so you can combine. So remember not, minus 6, it is together one. Then you go and times the half and times the minus 8. Okay, so you go and multiply all the numbers together. Okay, here you will get did I make a mistake? 824. Yeah, I made a mistake, you see. So you see, I didn't check just now and I made a mistake. See, minus 6 times half, you press calculator, is minus 3. Minus 3 times this, it should be plus 24. Okay, plus 24. So you see, So you should always check like what I'm doing now lah. Okay, so numbers all settled already. Now I'm going to settle the pi. Pi settled. Okay. Pi is a number also. Now we go to algebra. Algebra, anything to settle? Any x squared to combine with x? Oh yes, this x squared can be combined with x, so it becomes x cubed. Okay, and then now this final one,